Chapter 13. Communicative Tools with Rules. The origins and evolution of language have fascinated people for centuries. Linguistic skills emerge nearly miraculously in young children as they effortlessly acquire a sophisticated communicative repertoire without instruction. More striking, even skilled orators cannot readily explain the underlying, often complex, grammatical rules or hierarchical structures that lie beneath the serial flow of sounds that issue forth from their mouths. They just do it. How can we explain both the ease with which children acquire languages, as well as the intricate complexities of languages, which somehow emerge without conscious understanding among language users themselves? Converging lines of research from several fields now point to an answer. Languages arise from long-term cumulative cultural evolution. Like other aspects of culture, including sophisticated technologies, rituals, and institutions, our repertoires of communicative tools, including spoken languages, have evolved via cultural transmission over generations to improve the efficiency and quality of communication and to adapt to the details of local communication contexts, including physical environments and social norms, like taboos. Languages, then, are cultural adaptations for communication. These communication systems had to adapt, culturally, to our brains, exploiting features of our ape cognition, and at the same time created new selection pressures on our genes to make us better communicators. These genetic evolutionary pressures were powerful, shaping both our anatomy and psychology. They pushed down our larynx to widen our vocal range, freed up our tongues and improved their dexterity, whitened the area around our irises, the sclera, to reveal our gaze direction, and endowed us with innate capacities for vocal mimicry and with motivations for using communicative cues, like pointing and eye contact. The problem with many efforts to understand the evolution of language is that the lenses used are often focused too narrowly. By placing language within the context of our species' overall repertoire of communicative abilities, and then seeding this within culture-gene coevolution, we can begin to see the synergistic relationships between tools, practices, norms, communication, and language. Languages are a subset of culture that are composed of communicative tools, words, with rules, grammar, for using those tools. Many of the challenges to developing an account of the origins and evolution of language diminish once we, 1, understand how cultural evolution can construct complex but highly learnable repertoires without inventors or intentional designs, and 2, realize that language was merely one element in a broad and synergistic process of culture-gene coevolution. The idea is that among our ancestors, cultural evolution accumulated, integrated, and honed many useful communicative elements over long stretches of time into increasingly complex repertoires, as it did with our technologies and institutions. Since none of this leaves a material record for paleoanthropologists to dig up, we can't directly observe this accumulation. However, if I'm right, the communication systems of living and historically known societies will reveal various signatures of cultural evolution, which we can spot if we look closely. We'll first see that communication systems are adapted to the challenges of local environments. They are cultural adaptations, which include both the social and physical environments. Then we'll see that the conditions of cultural evolution can influence the size and complexity of communicative repertoires. Just as with technologies, the size and interconnectedness of speech communities influence their vocabulary sizes, phoneme inventories, and grammatical tools. If you are not a linguist, this all probably sounds reasonable, or at least not obviously silly. Why shouldn't languages operate like every other domain of culture? Almost no one would deny that the tools used by Tasmanians were less complex and fewer in number than the tools used by Victorian Aborigines or by modern Australians in Melbourne. Few would deny that societies possess quite different kinds of institutions, and that these institutions could influence economic success. Most would agree that, at least in principle, it's possible that the institutions possessed by Pama-Nyungan or Inuit speakers could have facilitated their expansions. Linguists and linguistic anthropologists, by contrast, have often assumed that all languages are more or less equal along all the dimensions that we might care about, equally learnable, efficient, and expressive. Accompanying this assumption is the view that languages are not strongly shaped by non-linguistic factors, that they are somehow hermetically sealed off from the rest of the world. Together, these two assumptions have inhibited cultural evolutionary approaches to language. Recently, however, the cracks in these intellectual barricades have begun to multiply as researchers use newly available language datasets to study languages as products of cultural evolution. Let's take a closer look. Communicative repertoires culturally adapt. There seems to be little argument about whether languages are learned from other people, that is, culturally transmitted. Even before birth, fetuses begin acquiring elements of the sounds and rhythms of the languages spoken by their mothers. Infants soon begin carefully watching the tongue and mouth movements of those around them and engage in vocal mimicry, providing themselves with immediate feedback for adaptive learning. Infant brains assemble specialized phoneme, sound, filters that allow them to effectively identify the sounds relevant in the local languages and to ignore the irrelevant ones. Around the end of their first year, children interpret pointing as a request to direct their attention at something and begin communicating with a combination of pointing and emotional reactions long before they talk. Infants and young children rapidly and unconsciously acquire elements of these communicative systems, using many of the same cultural learning biases, based on cues of competence, reliability, and ethnicity, dialect, that are used for learning about tools, practices, and social norms. Reference Chapter 4. Learners watch their models using words or gestures to do something, like help a friend, request information, or obtain a particular object. They infer what their models are trying to do and imitate those goals, desires, and behaviors. Meanings can be inferred from the rich context found in the routines of social life. Children's play often involves acting out scenes from adult social life, which uses language and other communicative elements in context and alongside non-communicative practices. From the perspective of the learner, communicative systems are just one important aspect of culture, a relevant local skill governed by social norms that has to be acquired, like fire starting, ritual practices, manioc detoxification, and taboo adherence. Of course, learning the local communicative repertoire gradually opens the floodgates to acquiring many more of the other locally relevant practices, beliefs, motivations, and ways of thinking. Operating over eons, this cultural evolutionary process has equipped human populations with powerful toolkits for communication. These toolkits involve complex repertoires of elements, including gestures, body positions, facial expressions, and vocalizations, which include clicks, whistles, grunts, growls, hisses, and squeaks. Like our toolkits for food processing, these systems have adapted to the local environments of their populations and are influenced by the same kinds of factors that influence other aspects of culture. Let me start with some of the non-speech elements of our repertoires, since these remind us that 1. Spoken language represents only one component of our communication system, albeit an immensely important one in modern repertoires, and 2. We humans can link meaning by inferring the intentions of communicators to an immense range of behaviors, not just to speech. Such systems may also provide insights into some of the earliest communicative systems used by our ancestors. Face-to-face spoken conversations are interspersed with lots of communicative gestures, as well as facial expressions. People in different societies variously point with their index fingers, middle fingers, chins, or pursed lips. Be careful, though. At least 2 of these are considered rude in some place or another. We shake hands to greet others, or sometimes refuse to shake. If you are in Fiji, make sure to do a long shake, basically hold hands for a bit. Elsewhere, people bow deeply, bow shallowly, or refuse to bow. To say okay or good, I give the thumbs up, or I circle my index finger and thumb in the OK sign. But do not use the OK sign in Iran or Brazil, as President Richard Nixon mistakenly did. It's like giving the finger in the United States. We nod our heads to say yes, but in some places that means no. For example, Bulgaria. Some peoples subtly raise their eyebrows for yes. Even ultra-verbal academics frequently use air quotes, an iconic gesture derived from the use of scare quotes in writing, to imply some disagreement with their terminology or its implications. I've seen many a humanities scholar, with a latte in one hand and a book in the other, struggle to communicate, unable to deploy air quotes to shield themselves from any undesirable implications of their words. Sign and whistle languages. Gestures, however, are not merely a communicative sideshow interwoven with spoken language. Fully fledged sign languages were common among hunter-gatherers, both in Australia and North America, and simpler gesture systems can be found across the globe, from African foraging bands to Christian monasteries. In North America, many groups of Plain Indians maintained their own tribal sign languages for hunting, warfare, and oratory at large ceremonies, and were conversant in Plains Indian Standard Sign Language. Plains Standard provided an important means of intertribal communication in a region of great, spoken, linguistic diversity. Using broad and open gestures, this language appears to be well adapted to communication over open plains, which favors a visual system over an auditory one, and for communication between individuals who might not want to approach each other too closely, as during intertribal communication. Probably because it was acquired after middle childhood, Plains Standard remained highly iconic, meaning that the signs contained elements of what they represented and relied on much standardized pantomime. The sign for bird, for example, involves flapping one's hands in a stylized way. For eagle, you first make the sign for bird, then the sign for tail, and then for black. So bird, tail, black would be translated as eagle. The grammatical system of Plains Standard employed space instead of any temporal or sequential ordering. The equivalent of noun phrases, for example, this black dog, for subjects and objects can be constructed in space at different locations and then connected by the relevant verb sign. The hierarchical structure of spoken languages, which so impresses linguists, is relatively easy to construct if one can sketch air pictures, as they were called, and essentially draw the links. By most accounts, Plains Standard possessed levels of expressiveness comparable to those of spoken languages, although signed conversations were quite a bit slower than in spoken language. As European descent peoples entered the Great Plains, they copied and used many Indian signs. See the Boy Scout Handbook. Among Aboriginal Australian hunter-gatherers, gestural signing systems of varying degrees of expressiveness and complexity have been documented across the continent, but particularly in the Central Desert. Some of these societies maintained fully fledged sign languages with the full expressiveness of their spoken counterparts. Elsewhere, the local sign systems possessed only a few dozen or a few hundred signs, which could be effective in particular contexts, like hunting, raiding, or during ritually imposed taboos on speaking, but didn't have the full expressiveness of spoken languages. Interestingly, the most developed sign languages tend to occur in populations with ritually imposed taboos on speaking that endure for many months or years. Often, as among the Walpiri, these taboos are associated with a period of mourning after the death of a close male relative. The length of the taboo period varies substantially with the closeness of the relationship, status of the deceased, and the unexpectedness of the death. For the closest female relatives, the taboo is maintained until the deceased spirit is avenged, which often takes about a year. Unlike Plains Standard, these sign systems are not particularly iconic and tend to follow grammatical rules derived from the local spoken tongue, although the sign vocabularies are heavily shared among groups. In the northern Central Desert, the closer groups live to one another, the higher the percentage of shared hand signs. This holds independent of the similarity of their spoken languages, and suggests that these signs were diffusing independently from the spoken languages. For our purposes, hunter-gatherer signing systems illustrate three important points. First, they appear adapted to their local context, to the functions they serve. Plains Standard, with its large iconic gestures, has evolved to foster communication among adults over distances or at large ceremonies. By contrast, the subtle gestures of Australian sign languages appear to be, in part, solutions to communication when ritually imposed taboos prohibit speech. In places where, for example, women cannot speak for months after a relative dies, sign languages achieve the same level of expressiveness as the spoken language. Ergo, non-linguistic social norms probably drove the development of these communicative systems. Second, the complexity or expressiveness of Australian signing systems vary from group to group across the continent. Some groups have a limited number of signs, a limited vocabulary, and rather underdeveloped grammatical systems, whereas others have the full deal. There's no argument that these various signing systems are equally complex or expressive. They aren't. Finally, the nature of the Australian systems suggests that they are learned by children, and thus the systems are not particularly iconic, unlike Plains Standard. Most hand signs lack any direct similarity to what they represent in the world. The reason is that iconicity aids adult learning, but when children learn languages, they strip out the iconicity. Remember, cultural evolution is smarter than we are, and so it has figured out many ways to facilitate communication. Now, let's consider whistle languages. Among remote populations from Turkey to Mexico, people can have a full conversation by whistling to each other, sometimes over long distances. Many of these whistled languages appear acoustically adapted for communication in steep, mountainous terrain, where households might be relatively close, perhaps across a gorge, but an hour or more away in travel time. Some of these languages use finger whistles that can communicate easily over 2 to 3 kilometers and up to 10 kilometers under the right conditions. Other whistle languages use lip whistles for casual, close conversations. So, cultural evolution can and has built various languages out of whistles because whistles were appropriate for the local context. Beyond whistles, anthropologists have found an incredible diversity of systems for communicating over distances using drums, horns, flutes, and gongs, among other techniques. Sonority. A successful communicator is one who can most effectively be understood, given the local social, environmental, or ecological conditions. As young or naive learners focus on and learn from more successful communicators who are using more effective communication tools, cumulative cultural evolution will gradually assemble sign or whistled repertoires over time in the same way that it hones kayaks, spears, and boomerangs. Given this, there's no reason to suspect that such cultural evolutionary processes somehow apply only to whistled or gestural sign languages and not to typical spoken languages. Thus, spoken languages should, under the right circumstances, show some response to the local acoustic environments and to non-linguistic social norms, just as whistled and sign languages do. While researchers have done little work on such topics, there's some preliminary evidence. Spoken languages vary in their sonority. The sonority of our voices decreases as the airflow used for speech is obstructed and is highest for open vowels like the ah, and lowest for so-called voiceless stops like the t in tin. Pronounce each of these sounds and note the difference in the constriction of your airflow. Both vowels and consonants vary in sonority, but vowels generally have much higher sonority than consonants. This means that more sonorous languages tend to have more vowels, for example Hawaiian, while less sonorous ones pack the consonants together, for example Russian. For the same energy and effort, more sonorous speech sounds can be heard at greater distances and over more ambient noise than less sonorous ones. If languages adapt culturally, then we can predict that in situations in which people do relatively more talking over greater interpersonal distances with more ambient noise and sound dispersion, languages will be more sonorous. Many environmental variables might influence this, but Robert Monroe, John Fott, and their colleagues reasoned that climate, and specifically temperature, might have a big effect. The idea is simple. In warmer climates, people work, play, cook, and relax outdoors. Compared to life indoors, living outside means that communicators more frequently face the challenges of distance, noise, and poor acoustics. Their team generated measures of sonority from word lists for dozens of languages, and then looked at the relationship between sonority and measures of climatic temperature, like the number of months per year when it's below 10 degrees Celsius, 50 degrees Fahrenheit. It turns out that if all you know is climatic temperature, then you can account for about 1/3 of the variation in the sonority of languages. Languages in warmer climates tend to use more vowels than those in colder climates, and rely more heavily on the most sonorous vowel, ah. For consonants, languages in warmer climates rely more heavily on the most sonorant consonants, like n, and By contrast, languages in colder climates lean more heavily on the least sonorous vowels, as the E in deep. This simple idea can have much nuance added to it. For example, not all warm climates are equally conducive to sonorous speech. In regions with dense forest cover, the advantages of high sonority might be less pronounced. Or, as the anthropologists Mel and Carol Ember have argued, very cold and windy climates may select against linguistic practices that involve opening one's mouth widely due to the increased heat loss. To this, they added the idea that social norms about sexual restrictiveness might also influence sonority. Adding both of these nuances to the basic climatic temperature analysis, they managed to account for 4/5 of the variation in the sonority of languages, or at least of the few dozen languages they had data for. This is impressive, though it's important not to overstate the strength of these findings. This research program is just getting started. Nevertheless, something is clearly afoot here. The basic relationship between climatic temperature and sonority has been tested in several ways and stood up to retests by different researchers. Given the way cultural learning shapes our tools, diet, and toolkits to local environments, it shouldn't be surprising if cultural evolution similarly honed our phonemic toolkits. Biologists have long been interested in how animal communication systems have adapted to the acoustics of a species' local habitat. Unlike language, much of non-human communication involves the deployment of a relatively fixed set of signals. However, research with monkeys, birds, and prairie dogs suggests that natural selection has calibrated these communication systems to diverse acoustic environments to make them more effective. Here we have a parallel case in which selective cultural learning has, well outside of conscious awareness, adapted our communication systems to fit their local acoustic environments. Cultural evolution can solve many of the same adaptive problems as genetic evolution, only faster and without speciation. Culturally evolving complexity, efficiency, and learnability. Shifting around the sounds used by languages is one thing, but can cultural evolution actually aggregate, assemble, and integrate linguistic elements, tools, and rules in the same way it does for food-getting technologies or archery packages? Can cumulative cultural evolution endow languages with greater expressiveness or efficiency? The evidence I'll soon discuss suggests that the answer is yes. But just as tool sophistication and tool kit sizes are limited by the systematic mistakes and misunderstandings inherent in the transmission of large and complex repertoires, so it is with languages. To survive and spread, languages, too, need to be learnable, especially by young children, and sometimes by adults in rapidly expanding groups. Thus, like other aspects of culture, we should expect vocabularies, phonemic inventories, repertoires of distinctive sounds, and grammatical toolkits to be influenced by factors such as population size and interconnectedness, as well as by the details of social networks, class stratification and ethnicity, technologies, for example, writing, and institutions, for example, formal schools. Vocabulary size. Let's begin with vocabularies. Words are tools for communicating, and having the right words can increase the ease, speed, and quality of communication. Although precise measures of the vocabulary sizes of different languages are difficult to establish precisely, rough estimates are sufficient because the differences are so big. Many of the languages carefully documented by linguists and anthropologists working in small-scale societies contain between 3,000 to 5,000 words. That's the entire dictionary. Meanwhile, slim dictionaries for European languages often contain about 50,000 words. A solid college-level English dictionary contains about 100,000 words, and the full-size Oxford English Dictionary contains more than 300,000 entries. Of course, this is totally unfair, since the dictionaries of non-literate societies reside entirely in the heads of speakers, until an anthropologist arrives, but European dictionaries reside in books and online databases, and few or no actual speakers know all the words. However, the average American 17-year-old knows 40 to 60,000 words, while their professors know about 73,000 words. These estimated in-the-head vocabularies contain 8 to 14 times more words than are available to the speakers of many small-scale languages, assuming they know all the words in their languages. These estimates no doubt exaggerate the effective differences in vocabularies, since many of the words missing from small-scale languages are words for pieces of technology, actions, or concepts, like satellites, sit-ups, and emoticons, that don't exist in small-scale societies. To get a perspective on this, let's consider two kinds of words that don't fall into this category: color terms and integer numbers. Languages vary in their number of basic color terms. At one end of the spectrum, English has 11 basic terms: black, white, red, yellow, green, blue, purple, orange, pink, brown, and gray. By contrast, many languages have no basic color terms, or only two, which are always black and white, or, more accurately, light and dark. In languages with only 2 or 3 color terms, a brilliant blue sky can be described as black and compared to the color of dark, dirty water. If a language has 3 basic color terms, they are black, white, and red, which usually partitions the entire color spectrum. Numerous languages have 5 color terms, which can be glossed as white, black, red, yellow, and green-blue, GRU. Of course, there are always ways around a lack of particular color terms, for example by referring to some object with the desired color, but this involves some linguistic work and is thus often less efficient. Ancient literary works tell the same story as the cross-cultural research. The Old Testament, the works of Homer, and ancient Vedic poems are remarkably vague about color, and at times devoid of colorful descriptions. Neither the sky nor the sea is blue. The worlds of these works are largely cast in black, white, and red. Terms for green, blue, and yellow, as basic descriptive terms, don't emerge until later in the literary histories of these societies. It's amazing that these rich, poetic cultural treasures are nearly colorless. Thus, color terms provide a narrow but clear window into language evolution. The color spectrum is actually continuous, so the borders between colors are arbitrary. The physics of light does not actually provide discrete categories like red and yellow. This could create a prickly problem for learners to solve. What region of the visual spectrum does the label red actually apply to? How can I, as a learner, converge on the particular region of color space that you mean by red? The answer may lie in the fact that while the actual color spectrum is uniform, our visual system perceives it as containing contours. Think of these contours as perceptual clumps or bumps in our cognitive color landscape that stand out. These contours might be genetically adaptive, reflecting things we have particularly needed to distinguish over our evolutionary history. Or they might reflect simply quirks in the system, created by the physiological mechanisms needed for perceiving color. Or some of both effects. Nevertheless, these contours help learners triangulate in on the local meaning of red or blue. Over time, color terms evolve culturally so as to maximize the perceptual similarity within a term. That is, examples or shades of red are perceptually more similar to each other than surrounding shades, even if these reds aren't actually any closer based on objective measures of hue and saturation. To be clear, these innate physiological perceptual constraints are non-linguistic in origin, but get exploited by cultural evolution to help us discreetly partition the otherwise continuous color spectrum using words. As with so many cultural adaptations, the system looks engineered for communication about color and fitted to the constraints of our visual perception. But of course, the only engineer was cultural evolution. As an English speaker, you have 11 basic color terms at your disposal because cultural evolution has figured out how to make them learnable. Meanwhile, Korean speakers have 14 color terms. However, most societies over human evolutionary history probably only had 2 or 3 color terms. Learning additional color terms influences our cognitive abilities and increases our gray matter, improving our discrimination and memory for different color shades across terminological boundaries at the expense of shades within the boundaries of one term. Of course, if you have more non-overlapping terms, you have more terminological boundaries. Integer numbers provide a potentially even more potent example. Since you are listening to this book, you have very likely received via cultural inheritance a linguistically encoded counting system that permits you to count without bound using only 10 numerals, along with some rules to structure them. This system permits you to easily distinguish a pile of 27 cherries from a pile of 28 cherries. However, this ability has not been available for most of human history. To our knowledge, all societies have number words for one, two, and many, and numerous societies count 1, 2, 3, many. But that's it. They can't count any higher. They can't, for example, use their counting system to distinguish those 2 piles of cherries. This fits with research in cognitive science suggesting that 1, 2, and 3 have corresponding innate mental representations. Beyond this, some small-scale societies augment their innate system using culturally learned body part counting systems that count objects or people by assigning them to specific body parts in sequence, like counting on one's fingers, but also using elbows, knees, noses, eyes, etc. In New Guinea, these systems top out at values as low as 12, but variously go as high as 22, 28, 47, or 74 in different societies. In some of these societies, there are ways to go through the cycle 2 or 3 times to obtain even higher values. Of course, populations have worked out ways around not having many integers, but groups with only limited numbers of integers usually rapidly adopt the more extensive counting systems of other languages when they get the chance. In children, full comprehension of both integers and color terms develops relatively late, at least compared to other aspects of language. Interestingly, Western children now master their basic colors at a younger age than they did in generations past, suggesting that the cultural system is evolving to be better at transmitting this knowledge. Acquiring these products of cumulative cultural evolution, integers and color terms, shapes our brains and influences our cognitive abilities. So, they provide specific cases of how expanding vocabularies influences our smarts. More broadly, Words are useful for thinking, so possessing a large vocabulary likely improves some kinds of problem solving. The active vocabularies of American adults, which is one component of IQ, have been increasing for at least a half century, and probably longer. While broader education at the university level can account for some of this growth, most of this expansion has occurred because adults have unintentionally continued to grow their vocabularies after their college years. This may have occurred because of shifts in the demands of many jobs in the United States during the 20th century. The upshot is that American adults score higher on IQ tests than their parents or grandparents did at the same age, in part because they have learned to use and understand more words. Finally, there's no reason why vocabularies couldn't have started expanding as soon as our ancestors were sufficiently good cultural learners. Non-human primates can already create mental categories or concepts for objects, banana, events, storm, and relational categories, rival. So cultural learning only needs to provide a means to connect these categories to particular gestures or sounds, that is, make words. Once connections are made, cultural evolution can cause these category-word relationships to become widely shared in a social group over generations. My point? Words are like other aspects of culture, and consequently we should expect the vocabulary sizes of languages to expand with the population's collective brain. As both color terms and integers illustrate, such additions are not merely incidental, but may give us new cognitive abilities and raise our IQs. Sound inventories. Along with words, the inventories of phonemes used by societies are also influenced by the sociality of populations. Of course, the sounds of spoken languages are constrained, at least in the short run, to the anatomy of our mouths, tongues, and air passages, but within the range of possible sounds, the variation is impressive. Rotokas is spoken by about 4,000 people on an island off the coast of New Guinea. The sound inventory of Rotokas consists of 11 sounds composed of 5 vowels and 6 consonants. Hawaiian, too, has 5 vowels, but combines them with 8 consonants. Among the Piraha in Amazonia, the men's phonemic inventory parallels the Rotokas, with 11 sounds. Piraha women, however, don't distinguish 2 of the consonants that men do, so it appears that they may have the smallest known inventory, at 10 distinct sounds. By contrast, English has roughly 24 consonants, and at least 12 vowel sounds, depending on the dialect. In southern Africa, Ko speakers use roughly 47 non-click consonants and 78 click sounds, and have a sound inventory of over 140 sounds. That's at least 10 times larger than Hawaiian, Piraha, and Rotokas. So languages vary massively in their number of phonemes. But why do they vary? Well, mostly we don't know, and detailed studies motivated by cultural evolutionary thinking are only just beginning. Nevertheless, one interesting factor may be that some people learn their languages in large communities with lots of strangers, where many interactions occur among people who share little in common. By contrast, in small-scale societies, children learn in relatively small and quite homogeneous communities. When learners do not share much in common and have to learn from very different voices with substantial variation in pronunciations across individuals, learners are better able to triangulate in on sound contrasts, and getting those contrasts is more important to understanding meanings. In small communities, minor sound differences can be missed in the learning process, in part because the people who are communicating tend to share so much background knowledge and context. This effect may create a tendency for larger populations in highly integrated market societies to maintain more phonemes than smaller, more isolated speech communities. Consistent with this approach, there is now evidence from several studies using different linguistic databases that show that languages with more speakers tend to have more sounds, that is, larger inventories of phonemes. Of course, the size of the phoneme inventory should interact with other aspects of language. If a language has more phonemes, it should be able to sustain efficient communication or expressiveness using shorter words. Since the selective processes of cultural evolution will favor greater communicative efficiency, languages that can support more total phonemes, due to larger and more diverse speech communities, can shorten their words. Indeed, several analyses also support this. Languages with more phonemes in their inventories tend to have shorter words. Overall, this growing body of evidence shows that larger and more interconnected populations tend to have more phonemes and shorter words. And while the analysis is not yet complete, there is also some reason to suggest that the words of larger populations will be better optimized for communicative efficiency than those of smaller populations.